Stern is in good company when it comes to his plea for choosing a near zero discount rate. Now, for the last reading of today, we have Pindyck, his Coase lecture, in which he expresses some additional reasons to favor a carbon tax over cap and trade policies. He argues that the negotiations over single or few tax levels may be easier than over nationally determined carbon budgets, and that taxes will facilitate international monitoring. Another part of the lecture provides some critiques on integrated assessment models and proposes an alternative way to measure the social cost of carbon. It is on this part of the lecture that I want to focus. I read from Pindyck, his page 349. Putting aside the discount rate problem, because of the current limitations of climate change science, these models simply make assumptions about climate sensitivity. That is, the temperature increase that would result from a doubling of the atmospheric carbon dioxide concentration. The models likewise make assumptions about the damage function. That is, the relationship between an increase in temperature and GDP. And the models, which generally focus on the most likely outcome, tell us nothing about tail risk, that is, the likelihood and possible impact of a catastrophic climate outcome, and the key driver of the social cost of carbon. The difficulty with the use of integrated assessment models for policy analysis goes beyond their arbitrary parameter assumptions and ad hoc damage functions. The greater problem, discussed in detail in Pindyck 2017, is that they create a perception of knowledge and precision that is illusory and can mislead policymakers into thinking that the forecast generated by the models have some kind of scientific legitimacy. Pindyck instead proposes to use an average social cost of carbon estimate rather than the marginal social cost of carbon that are estimated with these integrated assessment models. He does so with the following reasons. First, the estimation of the marginal social cost of carbon assumes that we are on the optimal path. Second, unlike the marginal social cost of carbon, the average social cost of carbon remains fixed for a period of time, providing stability for investors. Third, the average social cost of carbon estimates are less sensitive to the discount rate, as one discounts the benefits from a larger set of emission reductions or path of reductions rather than from a 1-ton change in current emissions. Fourth, Pindyck proposes to calculate this social cost of carbon using expert opinions. This does not rule out that various experts may wish to use their best integrated assessment model. Rather, the advantage is that this method is at least open about the subjective nature of the estimate and proposes a relatively tractable way to estimate it. Here we see the result of Pindyck, his exercise of estimating the average social cost of carbon for the coming 50 years, using responses from both economists and climate scientists separately. In summary, the social cost of carbon are notoriously difficult to calculate. However, the lack of consensus on the optimal level of the social cost of carbon should not hinder the implementation of a carbon tax on some politically acceptable level. This would help to establish that there is a social cost of carbon, and that social cost must be internalized in the prices that consumers and firms pay. Later, as we learn more about the true size of the social cost of carbon, the carbon tax could be increased or decreased accordingly. In my reading of the literature, the assumptions on the damage function are most problematic. Pindyck, 2013, page 868, points out, sometimes these numbers are justified by referring to the IPCC or related summary studies. For example, Nordhaus 2008 points out that the 2007 IPCC report states that global mean losses could be 1 to 5% GDP for 4 degrees Celsius warming. But where did the IPCC get those numbers? From its own survey of several integrated assessment models. Yes, it is a bit circular. The bottom line here is that the damage functions used in most integrated assessment models are completely made up with no theoretical or empirical foundation. I do not want to give the impression that economists know nothing about the impact of climate change. On the contrary, considerable work has been done on specific aspects of that impact, especially with respect to agriculture. Statistical studies of this sort will surely improve our knowledge of how climate change might affect the economy, or at least some sectors of the economy. But the data used in these studies are limited to relatively short time periods and small fluctuations in temperature and other weather variables.